All right, so we are back to our uh, series of design patterns. And now I finished to talk about solid and OOP. We are getting back to that. And I'm thinking about to create another kind of series, but talking about challenge. And not just the simple challenge that we can do on Let Codes, Hacker Hank, Code Byte, whatever, but challenge that we are performing in our interviews. So we'll try to explain that later. But let's get back here. So, welcome to another episode of our programming concept series. And today we're going to break down to the observer pattern, core behavioral design patterns that powers UI updates, reactive systems, and event-driven applications. So let's start to talk about the objective. The observer pattern allows an object to notify other objects automatically whenever its state changes without knowing who they are or how they respond. It establishes a one-to-many relationship between objects. So the definition, the observer pattern defines a dependence between an object and multiple observers. Whenever the subject state changes, it calls a method. Usually call it when you do some update or a click, I don't know, on all of its observers. Each observer reacts accordingly without the subjects being coupled to their implementation. So let's run some analogy here. So imagine a weather station, and we have this done here, but let's try to explain this. So imagine a weather station. It reads the temperature and notifies multiple displays, like an app, a wall screen, and a logger. The station just says, "Hey, the temperature changed to X, 25 degrees." It doesn't care how each display handles the update. That's exactly what the observer pattern does. Decouples who change the data from who reacts to it. So you should use the observer pattern when multiple components need to react to the same event. You want to avoid hard code independence between classes. You're building an event-driven system or UI updates, or you want to follow the open close principle. That's why I get back before and talk about the solid principles, and then we are getting back here and talk more about design patterns. So, common real world examples. So, UI frameworks like React, WPF, Angular, logging and monitoring, um, notification systems like email, SMS, webhook listeners, even queries and brokers, data async in distributed systems. So let's run some walkthrough here. So we have this temperature monitor. So first of all, I create the observer. So we have an observer that does this update. So in this contract, every observer must follow. Each class that wants to react to changes will implement this update method. And then we need to define the subject interface that it is. So the subject will attach, detach, and notify. And then we can create our weather station. So in our weather station, we have a list of observers that we don't care about it. So we have a list of observers, could be any, and we have a temperature, just a private. It could be uh, anything here. It's just a private property here. So we have the set temperature that is public, and we will receive the temperature. So here where the pattern comes to life. The set temperature map changes the internal state. Then it calls for notify, which loops through all observers and update them. Let's see here. When we have this notify, we run some iteration here to the all observers, so all the list of observers, and it does the update. What this update does, we can here check each observer. So each observer need to came from this interface. So let's see here. We have the temperature display. The update is display the new temperature. And the update logger, the update is logging the new temperature. So these are the observers class that react to the state change in their own way. So let's try to use the pattern here. When you came here to program, let's try to refresh our minds here. We are creating the station, and then we are creating the display and the logger, and we are adding those here. So the station will receive the display and the logger. We could create another one here, whatever. Var test. Oh, I love use test and new whatever here, and just attach, because our station, or in our station we can attach every observer. So we are here. So we create the subject, weather station, and the observers display and logger, and we attach them to the station. And anytime the temperature changes, both observers get notified. So here we are just creating, and then we are setting here. So first we set the temperature to 25, and then we'll set the temperature 28. And what will happen? We will see these updates. So the first update here, we have the weather station setting the temperature, and then we'll have those two next updates. So let's just run. So let's check. The weather station, first of all, I'm setting for 25. And then the observers is displaying. The temperature now is 25. And the logger is logging for 25. And then I set for 28. And now weather station is setting for 28. And the observer is displaying the temperature now is 28, and the logger is saying that logging temperature 28. So this is the output. Without the observer, you'd need to hard code each dependence. The station would need to know about the display, the logger, and whatever else come next. So with observer, you follow open close principle. You can add new observers without modifying the subject, and low coupling. The subject knows nothing about who's listening. So in a nutshell, the observer pattern is perfect when you want to decouple states change from reactions. It lets you build flexible systems where multiple components can subscribe and respond to updates automatically. Final note, Observer is a core piece of event-driven design and React architectures. It's everywhere, from UI components to messaging system and monitoring tools. Mastering it means write cleaner, modular, and extensible code. So for today, that's it, guys, and see you in the next video. Bye bye.